Okay, here's this homework question. And if you haven't read it, why don't you stop the video and take a minute to read this thing. So let's take a look at where some of the mistakes are. Now, the null hypothesis looks pretty good because we're using the parameter 75% is what we're looking at. But the alternative hypothesis should also be bigger than 75%, not our p hat. This should just be p, the parameter, not the sample proportion. Now let's see what else we have. Looks like the random sample, 558 middle school students were surveyed. That looks okay. I could be wrong on some of this stuff, but let's see. 558 times, that would be times 0.75, the parameter, not the sample proportion. And we also need to do 558 times 0.25. Remember, both of those have to be bigger than 10. They don't even talk about independence, which means that we have to have a population bigger than that. Now, the z-score, these two should be switched. It's p hat minus the parameter, not the other way around. And then also, those two should be 0.75 and 0.25, not what they have. And the sample size was not 445. That was the number of kids that said that they bullied people. The total number was 558. That's what should be there. Now, let's just say that this is okay. Well, look, they're doing a two-tailed test. They're multiplying it by 2 when they just said, is it larger than? So that's a mistake too. But anyway, let's just keep going. And then the probability that the null hypothesis is true is 0.0138. That is not correct. That 0.0138 is the probability that we would get a sample this much different if the null hypothesis was true. And then it says, so we reject the null hypothesis. I don't like this. This proves that 3/4 of the school engage in bullying. We never commit to anything in statistics, okay? We're just estimating. We think that there's a good possibility that we're going to go with the alternative hypothesis. Okay, so that's some stuff on that question. Let's go to the next one. Okay, now on the last question, I forgot, they didn't even mention the alpha level, so that's also a problem. Now on this one, in the back of the book, they give a pretty detailed explanation of all the stuff that you need. Now let's see. The null hypothesis is we're going to say the proportion of teens that pass is 60%. And then in this case, the alternative hypothesis is just that it's different. Either higher or lower, we don't care, just different than 60. Okay, so random, normal, independent, all that stuff. Random is stated. Independent, we're going to assume that there's over 1,250 teens, and then the normal is 0.6 times 125, and also 0.4 times 125. Are those both bigger than 10? And the answer is yes, they are both bigger than 10. So here we go. Let's do the math. So the proportion for our sample, okay, so that's going to be p hat. And what is that? It's 86 out of 125. So we are going to do a one proportion z-test. Okay. Or you could call it a one sample z-test. Either one of those is good. So let's take a look at that. Okay, so here's the z-score. And let's see, I got 2.0086. Anyway, I got normal CDF and then subtracted it from 1 and got 0.0221. 2, okay. So that's from normal CDF. Now I got to multiply it by 2 because it is a two-tailed test, which gives us pretty much 0.044. So this is our p-value just to determine if it's different, higher or lower, which is why we multiply it by 2. It is less than 0.05. So, very low chance that that would happen, so we are going to reject the null hypothesis in favor of the alternative hypothesis and say that we suspect that there is a different value than 60%. And that should do it for that one, I think. Okay, there you go. Okay, let's do the confidence interval. So it's p hat plus or minus the z-score thingy times the standard deviation of our sample proportion. There it is. So p hat was 0.688 from the previous problem. Plus or minus, now remember, we're going to do inverse norm. Now this is to get this z, and 0.997. No, 975, 0.975. And it should be 1.96. Let me check. Yes, 1.96. 1.96. And that standard deviation. So that is, now this is for our sample proportion, so 0.688 times 1 minus that, 0.321, 312, get it right, 0.312, and we're going to divide that by the sample size. I think that was 125, and we're going to take the square root of that. Okay, so remember, let's see, do all of this junk, right? Then multiply it by that number, and then add it and subtract it from that number. Or we could put it into the calculator, but it's good that we know how to write this down from the formula. Okay, let's take a look at this thing. So in the calculator, don't forget this letter A way down there, 1 proportion z interval. Let me write that down. So again, that's in the calculator. I'm going to put that stuff in there. We go to the menu. And what we end up with is, calculator says it's somewhere between 60, 7, 8, anyway, and then 7, 6, 9, 2. Okay, so that is our interval, our confidence interval. And letter B says, what does that tell us? It tells us that we're 95% confident that the true proportion of kids that pass their driver's test in the first try is somewhere between these two numbers. Now that 60% is really on the low side. So I have a feeling it's should be higher. It's not, I mean, we can't guarantee that, but it looks like it's going to be higher than 60%. Anyway, there you go. It's somewhere in between those two. Now 60% isn't out of the question. It's in that interval, so we're good. Wait a minute. That's wrong. 60 is not in this interval. Okay, 60 is outside that interval, which gives us fairly decent evidence that the DMV's claim is wrong about this statistic. There you go. Okay, let's go to the next one. Okay, here we go. We're going to ask a random sample of U.S. adults. Do they use some sort of social media of some kind? I thought this was interesting because they only came up with 20%. But then I took a look and it was 2009. You guys were just little kids. And cell phones were not that great. There were smartphones, but anyway, let's see. Can we use this interval to conclude that the actual proportion of U.S. adults who would say Twitter differs from 20%, justify your answer. No, we cannot say that it differs from 20% because 20 is contained within that interval, so we have to assume that that's a possibility. Okay, it's in the interval. That's your answer. Okay, I guess that's it. I'll see you tomorrow.